Hey folks, Jim here with Science Talk. Interesting two reports to share with you. And the first one involves what winter rain in Greenland is doing to the ice. Basically, it's helping the ice melt faster. In the first study I wish to share with you is published in the journal The Cryosphere. The One of the authors is Marco Tedesco of Columbia University's Lamont Doherty Earth Observatory. Wally Broker's old place. Okay. So let's see what this is about before I get into the second report that was published in the journal Science Advances. We'll get to that later on. Let me cover this one first. So, Greenland's ice is facing a problem that scientists had not identified before. Namely, that Greenland's winter rain is accelerating the loss of its vast ice sheet. And these two new studies, they're related. They have identified mechanisms for this event that's going on, for the ever-fasting melting of the ice. One is that the snow line keeps shifting. That's the second report. The other, and the snow line keeps shifting, is that alters the levels of radiation that's absorbed by the ice itself. And the other is that more snow and ice is simply washed away in the rainfall, even in the Arctic winter. Now that is alarming. Why? Because global warming has raised Greenland's summer temperatures as much as 1.8 degrees C by up to 3 degrees C in the winter months. Now you're going to sit there and go, that seems backwards. Why should there be more rise in the wintertime? You have high latitude, it's darkness. Well, what surrounds Greenland? Ocean. The latent heat energy coming off the ocean helps contribute that. The oceans are warming up more, so that latent heat gets released into the atmosphere, helping to warm the atmosphere more so than you see in the summertime. Remember, there's a lag between what we think of as the seasons on land. There's a lag with the seasons in the oceans. Reports of winter rain over an ice cap large enough, if it were all washed into the ocean, to raise global sea levels by more than 7 meters are a surprise, but that's what these researchers found. Glaciologists expect some melting of the polar ice caps each summer to be replaced each winter by snowfall that insulates the ice below and then endures until the following summer. Now, it has been previously thought that the ice caps, which most would shed their mass as the glaciers, calve off into the ocean and float southward. Well, this research, as I mentioned, published in the journal The Cryosphere, tells something different, and this is a surprise. Direct meltwater now running off Greenland into the sea accounts for 70% of the 270 billion tons, billion with a B, tons of ice that Greenland loses each year. Increasingly rainy weather is the trigger that sets off all this meltwater. Now, I just did a video talking about the permafrost and how rain, because it's coming earlier, is causing the permafrost to thaw even more, so releasing more methanes. Looks like we got a similar situation going on here. We have rain, it's probably coming earlier, and it's now drilling holes in the ice, causing more ice melting to take place. So German and U.S. researchers took data from 20 Greenland weather stations between 1979 and 2012. They matched this with satellite imagery. And the satellite imagery can distinguish between snow and liquid water. In the data, they identified more than 300 episodes of melting in which the initial trigger was the arrival of rain. During the 33 years of data, they found that melting associated with rainfall doubled during the summer months, tripled in winter. Nearly a third of all the flow of water from Greenland was initiated by rainfall. Warm air can melt ice, but more potently, warming air can turn what might have been snow into rain. That's the key point here. Liquid water carries considerable heat to soak into the snow and melt it. And the clouds that bring the rain have a way of conserving the warmth in the air. You have heard me mention before in the past that in the Arctic, sun energy is not the driver of temperatures, because the sun energy that comes in during the winter month, the tilt of the earth is such that the sun energy is dispersed over a great many square meters, so that it's weak. It doesn't really have much joules per square meter. But you get a cloud cover moving in, and that cloud traps the heat. The IR radiation. Right? UV energy in, IR energy out. The cloud's trapped in that energy. That's basically what's going on here. If you want to do a simple experiment at home, get an aquarium tank, whatever, 5 gallon, 10 gallon, whatever. Stick a bulb in there. Like one of those infrared bulbs that you see in restaurants to keep the food warm when it's ready. Stick a temperature in there. Have the top open. Okay, take your readings. And put a blanket over the top of the tank. Watch what happens to the thermometer. That's basically the principle at work here. Now, some of the meltwater will refreeze as surface ice that may be darkened by dust. Maybe some algae get in there. Now what happens is it can start absorbing solar radiation more efficiently than snow. And then the melt happens more readily and much earlier in the summer. In other words, the albedo has been reduced. Simple. This is simple physics. So, a statement by Marco Tedesco of Columbia University's Lamont Doherty Earth Observatory. Yep, same place Wally Broker worked. If it rains in the winter, that preconditions the ice to be more vulnerable in the summer. We're starting to realize you have to look at all the seasons. So that means you don't just go there in the summertime and camp out, but you have to go there in the wintertime. Most of the winter rainfall is in this island south and southwest, which is affected by warm ocean winds from the south, taking that latent energy from the waters and moving it over Greenland. These have become more common because warming has been linked to changes in the stratospheric jet stream. Polar vortex. This is what they're referring to. The polar vortex. So, why is the polar vortex changing? Why are the jet streams changing? Because the Arctic Ocean is having more and more open water, but also the ice is thinner, so that some of the sunlight energy can actually get through the ice. It's not as thick, and it's a little clearer than multi-year ice. Multi-year ice tends to be a lot more opaque, so there's more albedo. So now you're changing the local pattern there, which then translates to changing the wind patterns in the stratosphere. One of the reasons why the Arctic is warming so much is because there's more open water in the Arctic Ocean to absorb the energy. Okay, let's now consider the second study. Second study appears in the journal Science Advances. The lead researchers and authors is Jonathan Ryan and Lawrence Smith, both of Brown University in Rhode Island. And what they did was they looked at another related factor in why this melting is going on in Greenland, namely the snow line. Now, snow line can vary significantly from year to year, And again, of course, snow will be tends to reflect radiation. We have increased albedo with the snow, but ice, darker ice, will absorb the energy, so it's less albedo. So, what did the researchers do? They flew drones over Greenland, and there was a pause of a few days because it was a big, nasty storm, and they had to ground the drones. So when they got the drones flying a few days later, all of a sudden, boom, where's the snow line? It was gone. In a couple of days, they moved 30 kilometers or so up the ice sheet. It was out of the range of their drones. The drones couldn't fly that far. And that's when these two gentlemen kind of had a duh moment and said, maybe we should investigate the effects of snowline movement on melt. And basically, they're demonstrating that the snowline placement is important. And the study shows for the first time that simple partitioning between bare ice and snow matters more when it comes to melting than have been previously been given attention to in the past. So there you have it. More winter rain, making for ice that is darkened, so it melts sooner. So you have more melting of the ice come the next season, and moving snow lines. Moving snow lines changes the albedo. More energy could be absorbed as opposed to being reflected, with the result that Greenland is losing more and more of its ice than had been accounted for before. Thank you for your time. Hey friends, this is Jim reminding you to subscribe and share my videos. Also, don't forget to click the bell so that you know when I drop a video in. And I'm also asking for you to please support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your continued support.